So this is the entire coverage of the syllabus, which is in your this paper. In block 1, there is data collection and analysis, in which we will be studying collection of data, presentation of data, measurement of central tendency, then variation and skewness. Then there is probability and probability distributions. After that, in block 3, sampling and sampling distribution, and in block 4, forecasting methods. This is basically related to more research work, in which you will learn how to do a research and how to collect data, what is data, and how the collected data can be analyzed so that some decisions can be taken. As per, there can be any decisions related to just I will be taking today the part of block 1, which is data collection and analysis, how you collect data, how you analyze data. Yes, just I am sharing my presentation with you people. Just a minute. Okay. So I think it's visible now.
Yes, ma'am.
Okay, okay.
Yes, yes.
Okay. So, what is data basically? The data is the value or worth of any variable. Means the variable can be anything which you want to study, or anything which you want to analyze is variable. It can be like, if it's management related, then it can be if you are analyzing the sales figure with respect to time, then one variable will be sales and the other variable will be time. Time will be independent here. We will study in further slides also what is dependent and what is independent variable. So it is the value or worth of a variable, that is data. And data are assignments of values onto observations of events and objects, right? Like rainfall analysis is there. If you are studying rainfall, then you are analyzing an event, right? And if you are assessing the cost of the objects being manufactured in any organization, then you are organizing, assigning values to those objects. So the final definition can be facts or figures from which conclusions can be drawn is data. If you are just collecting something and you are not presenting it in a form or in a particular presentable form, then that is not data, that is mere information. Okay, so a type of information obtained through mathematical operations or numerical data. Now, data can take many forms. It can be anywhere and it can take many forms. It can include numbers, text, images, audios, and videos also. Right? You might raise a question over here that how can the data cannot be in the form of numbers? Yes, it cannot be in many times. So, I think many of you have just filled some questionnaires or surveys in which they analyze that how much satisfied are you from our product, or how many times you want this product to purchase again and again. So they are only analyzing customer satisfaction, and there are no numbers in that data, right? It is the quality of a researcher to convert any data in the form of numbers and then analyze it. But data can be in the form of numbers, text, images, audios, and videos also. And data can be raw or processed. Raw data means being collected primarily from the respondents, right? Which needs shaping, which needs some presentation, and it can be processed also. Like if you are collecting the population data from the site of the government, right? From where the census is calculated, and you are taking the data from there, then that will be processed data. So it is usually stored in databases or in other digital formats. These databases nowadays have increased so much, and you have so many languages to take data out from these databases. But in general, if we say what is a database is a storage of data in presentable form. As and when required, you can access whatever you want from that database. Now, data can be classified as structured or unstructured data. Structured data is organized in a specific format, and unstructured data is not, like such a table or a spreadsheet. A spreadsheet is basically related to computer softwares. uh, Excel is a specific spreadsheet software, and we have Google Sheets also. They are also a spreadsheet software. So these are some softwares which help you to analyze or organize data in a very structural form. So quality is essential to ensure that it is accurate, complete, and consistent. Okay. So what in if we talk about data quality, then it must be accurate, correct, complete, and consistent. Then only the data will prove useful. Now let's come to what are the different types of data. The one is primary data and the other one is secondary data. And also we have another classification in which we this classify data on the basis of quality and quantity. So if it is related to quality, then qualitative data, and if it is related to quantities, quantifiable items, then it is quantitative data. Now let's take each and every type of data one by one. The very first is primary data. Primary data means the data which has been collected specially for the purpose in mind. There should be, especially for the purpose means there should be a problem for that, and to find the solution of that problem, you are collecting some data. It Someone collected the data from original source. It is the first hand data. It is original source and first hand data. Like companies used to make you fill some questionnaires. That is primary data collection. They are collecting the first hand data. It has not been collected by anyone before. So research where one gathers this kind of data. So basically, the researchers use this kind of data uh, when there are when there is no already established data available for this purpose. So first of all, they identify what kind of problem or what kind of research they are going to take. Then they analyze whether they should collect the primary data or the data which is already available, which is secondary data, can be used to provide solution to the problem. So the main example or the foremost or the most usable example for any primary data collection is questionnaire. Questionnaires can be in any form, containing open-ended questions or close-ended questions, but they are very useful in collecting primary data. Then comes the secondary data. Secondary data is the data that has been collected for another purpose, means which has already been collected from for some other research. Every collected primary data becomes secondary data for the second research, right? So if the data is already collected, it is already published, already used, it is there in the books, it is there on the sites, then that is secondary data. So this is the basic difference between primary data and secondary data on the basis of their meaning, originality, adjustments. If we talk about meaning, then primary data is collected by researcher himself, and it is collected by other persons, not the researchers at the time. Yes, primary data is original, it is not original. Adjustment, yes, it does not need any adjustment because it is already focused to the solution of the problem, but it needs adjustment as per the actual problem or actual aim. Surveys, observations, and experiments and the questionnaires are the sources from where this primary data can be collected, and we have records, Government published data, books, in journals, etc. for secondary data. This difference of qualitative and quantitative will be more clear in the next slide. And the methods are observations, experiment, and interview for primary data. It is more reliable as compared to the secondary data. Yes, it is a time consuming method, right? Because if you want to collect the data of all the customers using suppose Dettol original soap, then you need to reach to every customer through mail or something. That will be very time consuming, but it is original and it is many times it is required also. Then it needs trained investigators for if you want to do collect primary data, you need trained personals. It is costly. Secondary data is basically inadequate, right? And if we talk about the capability, it is capable of solving a problem more than the secondary data, because that secondary data is calculated, is actually aggregated for some other problem. You are only using it because you think that this data is also helpful in your research. If we talk about biases, then primary data possibility of bias exists, because researchers are humans and they can be biased towards some cultural or societal or some only personal factors also. Like if you are in, say, if you are too emotional at a point of collecting, at the time of collecting data, then there can be some mistakes while collecting data, okay? Or if you are collecting the data from your friends and families, then also you can be more biased towards your good friends, and this is what a simple human nature. So primary data can be, there can be the possibility of bias, but in secondary data it is somewhat safe from biases. And yes, it is collected by a researcher and his agents, and it is already been published. Now, let's move on to qualitative data. Qualitative data is categorical measurement expressed not in terms of numbers but rather by means of natural language description. Yes, it is a measurement, it is a categorical measurement. There are categories in qualitative data also. For example, when if you see any such question that whether are you satisfied with the product, and the categories are not satisfied, dissatisfied, neutral, highly satisfied, and satisfied, then these are the what different categories of satisfaction. And the question is measuring the satisfaction level of the customer. So it cannot be in the terms of numbers, but it is a natural language description. This type of data is known as qualitative data. And yes, quantitative data is basically written down with numbers, like height is there, shoe size, and the length of fingernails, or the weight of different people, or the marks of different students in a class. So this kind of data is quantitative data. This I have. This is the basic difference. Subjective and objective and exploratory, etc. It is quite clear in the definition only, and that whether qualitative data, what is qualitative data and quantitative data. So let's move on to the very first representation, in which we use charts and diagrams for representing any data. These are the different names of the charts which can be used for representing the data in a pictographic form. Okay, we have bar charts, histogram, pictogram, pie chart, scattergram, and stem and leaf plot. Just take a look on this problem. These are the number of passengers with respect to year. Now, let's move on to what is bar chart. So, bar chart is a graph which in which the classes are reported on the horizontal axis. Generally, on horizontal axis, we take independent variable, and independent variable are those which are not in the hands of researcher. Okay, means if which cannot be changed or which cannot be varied with respect to the other one. So here we can clearly see the time horizon, which is 2005, 2006, 2007, 2008, 9, and 10. This time is independent on of this, right? These are the number of passengers for Air India from 2005 to 2010. We take it on x-axis, and generally on x-axis, always independent variable is taken. Then we plot the graphs like this, taking the amount and the bars for the particular year. I hope this bar chart is clear to everyone. Am I audible to you people? Because I'm not getting any
Yes,
reply.
ma'am.
Okay, okay.
Yes, ma'am.
So it is simple and easy to make the easiest diagram for everything, and you can compare between two things or objects or two variables. But the disadvantage of this is it emphasizes certain effects only. It can be reordered to emphasize certain effects only, like increasing and decreasing. But the basic effect or the identification of the variable which is being affected and why it is being affected cannot be identified with the help of with the help of bar graphs. You cannot also predict the trend on the basis of bar graphs. They are only the standpipes or the blocks which you can see. It can only be used with discrete data. Basically, this will be cleared in different other sites also. There are three types of data which we use in statistics. The one is individual series, the other one is discrete series, and we have continuous series. I'm just giving you some example for this. If you collect the height of 5 students and write it like this: 5 feet, 4 feet, 5 feet, 5 inches, 5 feet, 5 feet, 6 inches, then this is individual data. And if you talk about discrete data, then in this there are frequency for this, right? Suppose there are two students also for 5 and 4 feet. So you will write like this: 5 feet, there are two students. For 4 feet, there are one student. No, again, it is two students for 4 feet. Then for 5.5, it is 1, right? So in this manner, when there is the amount or the data which you collected and there is frequency of the data, frequency means how many times that data is being repeated. This type of data is discrete data, and continuous series are basically the series which we have in our 6 or 7 standards, and with the class interval like 10 to 20 and 20 to 30 and 30 to 40, and with this the frequency is given: 5, 10, 5, etc. So these are three types of data which we generally get in statistics: individual data, discrete data, and continuous series. We generally name them series also: individual series, discrete series, and continuous series. So this bar graph can only be used with discrete set of data or individual set of data, but not with continuous set of data. So this is the disadvantage of this bar graph also. Now let's move on to pie chart. It is the representation of something in the form of a circle. Pi is basically related to circle. Here the angles are used to define the percentage of the people. Generally, for analyzing the percentages, we use this pie chart because this complete circle represents 100% of anything. And so this is how pie chart looks like. You can make it in different shapes, like connecting also, disconnecting also, whatever you want. You can create gap over here, you can decrease gap also, but it should be in the form of circle only. So these are the advantages. Yes, it is visually very appealing, and just by a single look, you can identify what is being affected most. Like you can identify the higher percentage, you can identify the lower percentage. Since pie chart has percentages, so they are not 100% accurate, and they cannot compare two data sets, right? There is only one data set which can be compared with the help of pie charts. If you want to analyze, suppose with respect to time, you want to analyze demand and supply. You can analyze demand in one pie chart and supply in other pie chart, but not in combination. So you cannot identify or you cannot present two data sets in single pie chart. Then let's move on to line graph. It is very useful graph and it is a very good representation of the data. So a graph that uses points connected by lines to show how something changes in value as time goes. These type of graphs are used in stock exchanges also to predict the trend, to identify the trend which will be in future for any stock, right? All the time you might have seen whenever there is a stock exchange or something, they have these graphs and there are some lines going on. Even in, we can see this in medical also, analyzing the pulse rate, analyzing the heart rate for any, we use this line graph because it tells you the trend also, that how it is being repeated, it is going down and up in how much time. This cannot be analyzed through bar graph, but this can be easily analyzed through line graph. Then comes a scatter diagram. Scatter diagram shows two sets of numerical data to each other. These kind of diagrams are used in analyzing correlation between two variables, whether demand or supply are related or not, or whether sales and cost are related or not. So this is how scatter diagram generally looks like. In this manner, these are the values which we find at different points of interval, and these diagrams are very much useful analyzing correlation between two sets of data. If we have two sets of data, whether they are positively correlated, means if the value of one is increasing, the value of other is also increasing, and they are increasing in a very closed manner. And if the values are not related, suppose if a scatter diagram has one value here and other value here and then other value here, then here, it is very much scattered. It means those two variables which you are studying are nowhere related, nowhere correlated, right? So scatter diagram helps you analyze two set of data. It is very useful diagram and it helps to analyze a very important characteristics in statistics, which is correlation. This is simple pictogram. It is generally used in nursery or LKG or kindergarten classes to do the countings and etc. Right? So this is what a pictogram looks like. Stem and next, the last one is a stem and leaf plot. This displays the actual data as well as its frequency, right? So whatever the actual data is there, then its frequency, right? So in on x-axis we take frequency and on y-axis we take the stem. Suppose the values are 1 2 3 4, and with respect to 1, first frequency means which is 1, we have 9, then 1, then 2 and 0. So this data basic, this stem and leaf plot is generally used in forecasting techniques. We will take some examples if when we will be able to understanding how we do forecasting, what is correlation and regression, then I will be explaining you this in more detailed form, how this stem leaf diagram is maintained. Now, this was the pictographic representation of data. Now, this pictographic representation can give you some highlights. But if you want to take the more intrinsic view of your data, then you use to analyze that data with the help of statistical tools. And in these statistical tools, the very first tools related to statistics or related to analyzing data are of central tendency. See, just go with the name, central tendency. Tendency means what? Tendency is something that is being repeated or something that can be represented as a particular class. Suppose there are 5 students and they all are naughty students, then you can say that these 5 students have naughty tendency. Suppose you meet some students in a class and you say, you see they are very sincere and having good marks, then you can say this class has tendency of generating toppers. So central tendency is where the data revolves around it, right? The complete set of data which you are analyzing revolves around it, then that is central tendency. And there are many measures for central tendency. The very first measure of central tendency is average. Central tendency जिसको हम we say it average value also, and average is a very powerful technique. It is the single value which is considered as the most representative or typical value for a given data set. We all know what is average. Average basically represents the whole data set, right? It is a value nearest to the smallest and the largest value, and it is not the smallest or the largest, right? It is the middle value of that group. So the very first thing, let's move on to the example, the very first tendency, which is arithmetic mean. And arithmetic mean is average. So arithmetic mean is usually denoted by the symbol X bar. Whenever you want to write arithmetic mean, you use this symbol, which is X bar. Okay. And how is this X bar obtained? This is basically sum of all the data, all the numbers of the data which is given to you, and divide with the number of data, right? So let's take an example for this. Suppose there are 10 students and the roll number of those 10 students are given to you. The first student has got 43 marks, the second student has got 48 marks, third student has got 55 marks, and you want to identify whether this class belongs to first class category or not. Okay, then what will you do? You take the average. Okay, so when you want to take the average, this is the formula being used for taking average. You have X bar summation of X divided by N. Then what you do, you just add all these values: 43, 48, 55, 57, 21, 60, 37, 48, 78, 59. Then you get 506 and you divide it with 10. Then the answer will come, average is equals to 50.6, right? So this class does not belongs to the first class category because that is having 60% and above. Okay, but this can also belong if the total of marks is 80. Suppose this calculation is done out of 80, not out of 100, then it can be possible. But as an average, you can take that in this 50.6 is the representation of this class. No matter the lowest value is 21 and the highest value is 78. The average belongs to 50.6 category. Is this clear? And this type of data is known as individual series data. Is this clear to everyone how to calculate average?
Yes, ma'am.
Okay. Of individual data series. Now let's move on to the frequency distribution. If there is frequency distribution given, then what you do, you multiply the particular frequency with the particular data and add all the frequencies for that. Let's take the example for this. From the following data of marks obtained by 50 students of a class, calculate the arithmetic mean. We have marks 20 obtained by 8 students, 30 marks obtained by 12 students, 40 marks obtained by 50, and so on, like 50 by 5, 60 by 6, and 70 by 4. And if you want to take the average of this, then this number of students will become your frequency, and marks will become the data which you are analyzing. So what you do, you multiply all the corresponding frequencies with the corresponding marks. So 8 multiplied by 20, 12 multiplied by 30, 15 multiplied by 40, and so on. And in the end, you add all these marks, then the total is 2010 over here. Then you take average 2010, and this 50 is summation of f, which is the frequency. So 40.2 is the average for this entire class, and this type of data is known as discrete series. So I think this is clear how to calculate the marks in discrete series, average in discrete series, just arithmetic mean. Now let's move on to the last series, which is continuous series. So it is the sales data, 0 to 10 lakhs, 10 to 20, 20 to 30, till 60 to 70. And we have 6 firms whose sales belongs to 0 to 10 categories, 5 firms whose sale belong to 10 to 20, 8 firms whose sales belong to 20 to 30, and so on. Now what we do? We just make the table like this. We have sales, which is X, the data which is being analyzed, and we identify the mid value. Mid value is quite easy. You add the lower and the upper limit and divide it by 2. So 0 plus 10 divided by 2 will give you 5. Then in this case, 10 plus 20 divided by 2 will give you 15. In third case, 30 plus 20 divided by 2 will give you 25, right? So this is how the very first thing in continuous series, for calculating arithmetic mean, you have to identify the mid value of the class interval. So we have 5, 15, 25, 35, 45, 55, and 65. And we have the frequency which was given in the question. Now what we do it same as in discrete series. We multiply frequencies with the values. We will do 6 multiplied by 5, 5 multiplied by 15, and so on. And in the end, we will calculate the sum of this and sum of frequency and divide it.
Ma'am, I got one question.
Yes, yes, yes.
If the mid values come in decimal number, then what we will do? We'll get it, like we'll take it as it is, or we'll round it off. Like
No,
decimal up to two values.
yes, you can. You can take it as it is. Just no need to round off that,
Okay.
right? You can take it as it is in the decimal value. The answer will come accordingly, because average can be 50.6, 70.8,
Yes,
or
yes, yes.
anything, right? Okay.
Okay.
Then you divide it. So here the average is 33.4 lakhs. Now, there is one, so these are the different types of series. These were the different types of series and how you calculate averages. Now, there is one shortcut method also, which is known as assumed mean method. In this formula is used, where x is equals to a summation of f into deviations from that assumed mean, and n is the number of observations. See, prior to this, there were no when there were no calculators and etc. These shortcut methods were very useful, right? But nowadays, because we have calculators and computers and big softwares and programming is also there, we can do this in seconds. So we don't give too much importance to shortcut method, but you should know every method, because these can be adopted, these can be easily, these will give you easy answers if there are values in very large numbers are there, or large number of values are there, then you can use this shortcut method also. Now let's take an example for this. The same example we can take. This was already discussed with you people. Same example ko shortcut, I have explained the same example with shortcut method. So let's move on to this slide only. So these were the mid values: 5, 15, 25, 35, 45, 55 and 65. Just by taking a look, we assume that 35, suppose 35 is the mean of this entire data. Then what we do, we find out the deviations from assumed mean. How your value, the value which is there in the data set, is how much it is deviated from the assumed mean. So basically, deviation is mid value minus assumed mean. So 5 minus 35 will be 30, and 15 minus 35 minus 20, 25 minus 35, 10, 35 minus 35 will be 0, 45 minus 35 is 10, 55 minus 35 is 20, and 65 minus 35 is 30. So these are the deviations. Okay, and here assumed mean is 35, right? Then these are the frequencies: 6, 5, 8, 15, 7, 6 and 3, which was given in the question. Now what you do, you multiply this frequency with these deviations. So minus 30 into 6, minus 20 into 5, then minus 10 into 8, then 0 into 15, 10 into 7, 20 into 6 and 30 into 3. Then you have to add this. So here the assumed mean is 35, n is 50, which is sum of frequency, and summation of f minus d is coming minus 80. Then you put it in the formula, which is assumed mean summation fd upon n. And you find out this, you when you calculate this, it will come 33.4. The answer will be same from shortcut method also or from long cut method also. But if the values are very large values, then we can use shortcut method also for that. But I think calculators are allowed in your examination. So it's up to you whether you are using shortcut method or the simple method for calculating assumed mean.
Ma'am, I have a question.
Yes, yes, yes.
So, like, in real time scenario, here we are calculating with like 7 or 8, set of data. But
Hmm.
in case there are larger number, and if we use the assumed method, right? In
Hmm.
that, will the result will still be the same, or it will impact? And second thing is, suppose the if the based on the assumed method, right? If
Yes.
like in some cases if we are doing a prediction, so will that prediction will also get impacted in case?
See,
Yeah.
you know, the basic rule of statistics is 99% of accuracy.
Yes.
If there is very large number of data, it can be, if you apply shortcut method, then
Mm-hmm.
your average can vary with a very slightest difference, right? There will be difference, but like in points or something like there.
Mm-hmm.
And in real life situations, when you are applying statistics, you know, you apply statistics in every kind of research, whether
Mm.
that research is related to medicine also,
Correct.
right? So in that case also, statistics gives you the probability only. It is the 99% chances of being accurate,
Okay.
whether it is for drug testing or anything. We cannot give the 100% correct answer with that. Okay,
Okay.
so it is based on probability and assumptions, yes. And secondly, the answers can vary in slight manner.
Okay, got it. Thank you.
Ma'am, in
Yes,
large data, we can have like upper limit and lower limit, right?
yes.
Yeah. And like that, your example does consist of seven digits, I guess. Can you scroll up the screen a little bit?
Hmm.
So we assumed the mid number, that is 35, as like assumed mean, right? We took 35 as A.
Hmm.
So just in case, if the data is in even numbers, so can we add two mid value like 35 and the very next to it, and we can divide it with the total number of data, then we get that assumed mean. Is this the correct method?
It is not required in central tendency to take the average of the middle value or something. And I have not taken the middle value with the position also, because arithmetic mean is not positional average. It is the value which you think can be the mean or the central tendency of this entire data set. This is the drawback also of arithmetic mean. It is not the positional average. So you can, if there are seven numbers also, or if there are six numbers also, there can be 45, 59, 68, any numbers which you think can be the mean of that, not with the position. Arithmetic mean is not a positional average. This 35 can be written in the last also with the frequency. Okay, so it is
Okay.
not related to the position. I think, am I clear to you?
Yes, ma'am. Okay.
Okay. That position average is basically median. Then there is, we always first arrange the data in the ascending or descending order, right? Nice observation. The next one is a step deviation method. It is it is more simplification of shortcut method. Here this C also added, which is common factor. Let's look to the example of this. These are the marks and these are simple number of students, and let's do it with this step deviation method. So 0 to 10, 10 to 30, 30 to 60, and 60 to 100. We calculate the midpoints 5, 20, 45, and 80. Then we calculate, there is the frequency 5, 12, 25, and 8, which is given. Now here comes the deviation. Now you see, if from 5, 20, 45, and 80, we can take 5 common, right? So this will become 1 and 4 and 9 and so on. So what we do, we take this 5 common, and here this C will be 5. So now what we do, m minus 45 is the deviation, and we divide it by 5 also, right? So 5 minus 40, here, see here the average is taken 45, assumed mean is taken 45. So 5 minus 45, then we divide it by 5. Okay. 5 minus 45 will be 40, and divided by 5 it will be 80. So we have just more simplified it only in this method. We have now minus 8, minus 5, 0, and 7. Now the same thing, we multiply f with these deviations. So we multiply frequency with this, it will come minus 40, then 12 into minus 5, it will come minus 60, 25 into 0, it is 0, and 8 into 7, it is 56. Then we add all these, we got minus 44, and the sum of frequency is 50. Simple, put it in the formula, where assumed mean is 45 and summation of frequency and distribution is 44. Frequency is 50 and C is the common factor which we took from our mid values of the class intervals. And then you will be getting the answer here, which is 40.6. If it is not written in the question that you have to perform it with the step deviation or shortcut method, you can do with any method you like. Okay, but if it is written, then you have to perform according to the question. So my advice to you is, go with all these three methods, and try to solve some more questions related to central tendency. And please take one question from each type of data set. Always remember, study statistics from type of data set, because once you become a good researcher, or if you are in a marketing, yes, do you want, someone is asking anything?
मैम ये सी वाला एक बार फिर से समझा दीजिए, जैसे हमने 5 लिया है, वो 5 ही क्यों लिया है बेसिकली, फिर से
5
समझा
इसलिए
दीजिएगा।
लिया, यस यस, एक मिनट बेटा। 5 इसको ना मिड पॉइंट्स में से आपको एक कॉमन फैक्टर लेना होता है, राइट? तो यहाँ पे जितने मिड पॉइंट्स हैं उन सब में से आप क्या कॉमन ले सकते हो? देयर इज 5, 20, 45 एंड 80। एक तो आप 1 कॉमन ले सकते हो, पर उससे कोई फायदा नहीं होगा, क्योंकि ये वैल्यूज 5, 20, 45 एंड 80 ही रहेंगी। ओके, तो यहाँ पे इन्होंने 5 कॉमन इसलिए लिया है बिकॉज 5 से आप सारी वैल्यूज को डिवाइड कर सकते हो। सो दिस विल बिकम 1 एंड you know the table of 5, na? You know how to take common.
Yeah.
I hope so.
तो
So that is why we have taken 5. Okay.
तो मैम सी सी लोएस्ट नंबर ही रह सकता है या बिगर नंबर भी रह सकता है, या फिर
Beta lowest, it will be lowest because you have
ओके
to take common from everyone, na? You are taking
एंड
common 5 from this also, 5 also.
एंड मैम ये मिड पॉइंट जो गिवन टेबल होगी वो उसी में ही, मतलब हम लोग को उसी टेबल लेना होगा, कि हम लोग अपना ज्यूम भी कर सकते हैं कि ये 10 से डिवाइड हो रहा है तो 10 से कर दें, ये 9 से डिवाइड हो रहा है तो 9 से कर दें,
No,
5
no,
से हो रहा
no,
है तो
no.
5 से
The
कर दें।
calculation of midpoints are you have to add this lower limit, higher limit, and divide it by 2.
That I understood.
Yes.
According C को लेने के लिए बेसिकली आई वाज आस्किंग
C को
अगर
लेने के लिए this C
हाँ
word, yes, you
हाँ
have
तो
to
मिड
take
पॉइंट हम
C.
लोगों ने निकाल लिए,
Hmm.
तो जब हम लोग मिड पॉइंट निकाल लिया तो उसमें से लोवेस्ट वाला हम लोग ले लेंगे, बट वो डिविजिबल होना चाहिए सारे उसमें मिड
यस
पॉइंट्स में,
यस
राइट?
यस, उससे सारे मिड पॉइंट्स डिविजिबल होने चाहिए। ये जरूरी नहीं है वो लोएस्ट ही पॉइंट हो, वो कोई और मल्टीपल भी हो सकता है। सपोज यहाँ पे मिड पॉइंट आपका 30 ही आ रहा होता, तो आप तब भी 5 ले सकते थे, राइट? यस, जो आपकी मिड वैल्यूज आ रही होती वो 10, 20, 30, 40 आ रही होती, तब आप 5 भी ले सकते थे, 10 भी ले सकते हैं, राइट? इट्स नॉट द लोएस्ट ऑल्सो, इट इज द कॉमन मल्टीपल विच divide
ओके ओके
these all the numbers, leaving no remainder.
ओके ओके, so it should be in single digit so that the answer would be more easily
Yes, yes, yes.
taken. Okay, thank you.
Welcome. So next tendency, central tendency, is the positional average, which is known as median. Here comes the role of position. Very, very important average it is. It is also an average, but it is positional average. So median is the middle value after the observations have been arranged in ascending or descending order of magnitude. This is the very important thing, since it is a positional average. What comes on the mid position, right? So that is why you need to first arrange your data into ascending or descending order. Then only you can identify the mid value and the median. Suppose these are the marks obtained by 12 students out of 50, 25, 20, 23, and you have to find the median for this. Then what you do, you just write all the numbers in ascending or descending order and find out the mid value for this. Now here the number of items are 12, right? So आपको clearly by observation you cannot identify the mid value. What you do, you take the two adjacent mid, where the two the values where the mid value will lie, two adjacent values. So in this case, the 6th place, which is 25, and the 7th place is also 25. You take that and you take the average of these values, then you will be getting the median value, right? Suppose if there were 13, then it was quite evident. You take the mid position value from this, okay? So this is how you calculate median for individual data set right? What you do, you arrange all the numbers in ascending or descending order, and by position, you analyze which comes in the middle. If the numbers are even, you take average, and if the numbers are odd, you just take the mid value. So this is the median in this case. Now comes the discrete case where we have frequency. And how will you identify when the frequency is given to you, the mean? Okay. So let's move on to this. We will be able to understand this from this example only. There is income given to you 1000, 1500, 800, 2000, 2100, and 1700. And we have number of persons 24, 26, 14, 10, 5, and 8. So here income is the variable which you are analyzing, and number of persons is the frequency for that. So now what you do, just a minute, ये PPT से PDF में convert किया है तो वो locked हो गया है. Let me tell you this. Just a minute. I think it's clear. It's visible now.
Yes, ma'am.
Yes, ma'am.
Okay. So this is income. First, you arrange it in ascending or descending order. So I have arranged it in ascending order, which is 800,000 and like that. Uh, and this is the frequency, number of persons belonging to the category of the income. Now, what you do, first of all, you calculate CF. CF is basically cumulative frequency, in which we add on the previous frequency and till the end. So what we see here, we have 14, we write it 14 like this only. We have here 24, and we will add the previous frequency. 24 plus 14 is equals to 38. Then 26 plus 38 is equals to 64. Then 28 plus 64 is equals to 92. And then 10 and 92 will be 102, and 102 plus 5 will be 107. So you add on the previous frequency in your result, then you will be getting this cumulative frequency. Now, the last cumulative frequency is 107. Now you have to identify the median, which is size of n by 2th item. Here n is 107. You divide 107 by 2, which is 53.5. This 53.5. Now what you do, you locate the cumulative frequency where this 53.5 will come. So here it is 14, then we have 38, then we have 64. So this 53.5 will come in this cumulative frequency. So from here you see that the average, the median for this will be 1500. So first you identify your frequency, your the size of the item which is coming in which frequency distribution. Then corresponding value for that distribution will become your median. I hope this is clear, or should I explain it again?
मैम 107
Yes.
लास्ट में, तो वही लिया जाएगा, मतलब जो लास्ट में वैल्यू आएगी वही लिया जाएगा, या कैसे इसको करेंगे?
ये n
तो
n
सर
by
फिर से
2th
समझा
आइटम
दीजिए।
कैसे निकालेंगे?
यस मैम।
n by 2th n यहाँ पे जो है ना, वो आप दोनों तरीके से निकाल सकते हो। ये फ्रीक्वेंसी का आप सम करोगे तो भी 107 ही आएगा, राइट? तो
ओके
लास्ट फ्रीक्वेंसी आप लो या आप फ्रीक्वेंसी का सम कर लो, दीज बोथ
ओके
आर द सेम थिंग्स. Okay,
ओके
so this n by 2 is whether you are taking last cumulative frequency or you are adding all the frequencies, you will get the same result. So here n is basically sum of frequency only. So
ओके
107 divided by 2. Here is 53.5. Just locate 53.5 will come in which cumulative frequency. Then it is coming here in the third one. The value of x corresponding to this will become median. Okay?
ओके
Okay. So this is for discrete series, right? Mm. I will be sending you the PPTs for which I have discussed in this thing. Let's move on. If you have some 4 minutes more to understand, so that we can complete this different types of data set for median. So we have continuous frequency distribution. You all know that what is continuous frequency, like 10, 20, 30, and 40. And this is the formula for calculating median for continuous series, where L is the lower limit, L2 is the higher limit, L1 is the lower limit, F is the frequency, and M minus CF. M is the mid value, and CF is the cumulative frequency for that particular class interval. Okay, cumulative frequency of the class preceding the median class. And median class we will locate with the same method like n by 2th item. Let's move on to the question for this. Suppose this is the question where profits are given and number of firms are given. Let's move on to it like this, in this form. So this will be X, this is your firm, and which is frequency, and these are the cumulative frequency. The very first thing which you have to do it, you have to find out the cumulative frequencies for this. So it's the same, we write 4, then we will 4 plus 5, then 9 plus 11, then 20 plus 6, 26 plus 5, 31, 31 plus 8, and so on. This is how you will calculate cumulative frequency. The next step will be to identify the median class. Okay, so for that, what you do n by 2, which is here it is 60, 60 by 2. This 60 can be the sum of this also, which I already told you. Now you find out the cumulative frequency just greater than 30 is 31 and is corresponding to class to 35 and 40. See. So 30 will come in this category and your median class will become 35 to 40. This will become your median class, right? And for once you have allocated the median class, you know the lower value will be L1, which is 35 here, and the upper value will be L2, which is 40 here, right? Now we put all the things in the formula. I think you people can try it on your own also. Here, lower limit will be 35 plus 40 minus 35 upon frequency. Just a minute. This 30 minus 35 has the frequency 5. So you can divide it by 5 and the mid value of 35 and 40, right? 30 plus 40 divided by 2, and the CF, which is corresponding to the previous class, right? The CF will be 26. So with this, you can calculate the cumulative the median for the continuous series. There is one more example given to you. You can calculate with this also if you want to do that. So this is how we calculate median for all the types of series: individual series, discrete series, and continuous series. In next classes, we'll take some more example of median, and then we will go to the mode, which is the next tendency. It is the central tendency only, but it is also related to positional average, right? Median and mode, they both are the positional averages for it. Okay, so do we have, if you feel any query or something, you can ask me in other lectures which are scheduled as per the schedule. You can ask me for that. And try to read it down more from your syllabus books if you have that. And if you don't have that, just go with the online study material. All these things are also there in the study material, because the lectures given to us are only four, and four lectures, the entire schedule cannot be covered. So I will try to cover the maximum and the important things which are being generally asked in the question examinations. And that's it for today. If you have any queries and problems, you can ask now also, or in other classes also. In other
इसका
classes,
आंसर क्या होगा?
have you calculated the answer? I haven't calculated it actually. I left it like the problem for the next class. Have you calculated it, Siddharth?
Mine's coming 64.
64 is coming. Just a
Yeah.
minute. How it is 64? Let's check it once again. We have this 35. 40 minus 35 will be 5 upon 5. 35 plus 40 divided by 2 is coming, I think, 37.5 minus 26. So, am I correct or not?
And 35 plus
5
40 is
plus 40
75.
divided by 2 is also there. Okay, okay. So 37.5, just a minute. 35 plus 40 will be 75, and divide by 2 it will come 37.5, right? Then 37.5, if you subtract 26 from here, we will be getting 11.5. This 5 by 5,
46.5.
if we select, if we minus
Mm-hmm.
37.5, if we deduct 26 from 37.5, we will be getting 11.5, na?
Yes, yes, yes. तो उधर
Then
तो गड़बड़
35
हो गई थी.
plus 11.5 will be the answer. Okay,
46.5.
46.5. And I got this intuition that 64 is basically incorrect, because 64, here if you see in class intervals,
Mm-hmm.
na, median class was 35 to 40, means median will lie somewhat here or somewhat in 40 to 45. It cannot lie in 60 to 64, because it is a positional average. That's why I
Calculation
got it
mistake.
as okay. Okay, okay, no issues. So this is how you will calculate it. Just let me take the screenshot for attendance. Okay, thank you very much. In other classes, we will be. What is, it's already there. I'm not getting.